Hi everyone, my name is Oded. I'm the CEO and the co-founder of Akeyless, the secrets management company. I have a history of about 20 years in the realm of identity and access management. I've done some time in the Israeli Defense Forces, and I have, let's say, lots of experience with the identity management, the privileged access management world, information security in general. And 3 years ago, we founded Akeyless as the secrets management company. We basically have a SaaS Vault platform that is globally available. We're leveraging our own unique core IP, core technology named Akeyless DFC, Distributed Fragment Cryptography. We're acting as a root of trust as well as privileged access and secrets management solution and zero trust solution, already serving lots of companies, market leaders in their fields. You can have some of those. So this is where I come from. So talking about the history of secrets management and how things evolve is actually a very much interesting story about the combination of data protection and identity management. And with the last few years, we have also gathered in the story of cloud security. So I'll get to that in a few more minutes. So the step one that I wish to start with is about protecting the data. When you have a data either on your on-prem or whatever it is, and right now in this section, I'm actually talking about some, stuff that we used to have for years now. Some of them have been changed in the last few years, considering the cloud. But for years, in order to protect data, you had to control the access. Who has the access to that data, and who has the identity? How can you validate the identity that someone is trying to fetch a certain data? And the other mechanism with protecting the data is obviously to encrypt that data so no one can access it. But then you have the problem of who can access the key, right? Because you encrypted the data and then the data is encrypted. Now you have a key, and then where do you place that key? There are all kinds of solutions. We'll talk about that. But eventually, you would need to validate also the identity that wishes to access the certain key. So as a result of what I'm now saying is that a data encryption, data protection, and identity validation, those two are tightly coupled. Now, in terms of identity validation and how to do so, obviously we're getting to the term named authentication, right? And there are two types of identity that need to authenticate in any case. There are the human that need to authenticate to a certain application, and then we have machines that are being required to authenticate also. So, and I placed here a very common example where a user would like to have a password in order to authenticate to that application. And behind the scene, this is something that users usually don't see. The application itself would require some kind of a database password to go into the database and to fetch the actual data, or the ability to fetch whatever encryption key in order to decrypt the data. So it's not just about having one password from the human to the machine. When I'm saying machine, I mean obviously servers and containers and whatever that is running the algorithm of the application. So eventually we're talking about two types of authentication, so two types of identities. Now, those identities, when we talk about passwords, we also talk about credentials or API keys, certificate, SSH keys, things that you see in front of you, but we tend to call that in one name the secret, right? I need a secret in order to protect my data. Okay, sometimes we say my data is the secret itself. So I wish to let's do place some order in those terminologies. So the data itself can be considered a secret, but the data is being protected. When I'm saying secret, I mean all of the authentication and authorization objects that you need in order to access your data. Okay, so there's the authentication phase, the identity validation, the password, the credentials, those are the secrets. The encryption keys are the secrets, and then there's the data itself. Okay. Now, the next thing was when people have obviously implemented data protection, encryption, and also authentication processes and authentication protocols. we've seen the rise of privileged access in the beginning of 2000, 2005, 2010. We've seen a great rise of that market. Privileged access basically meant that we've seen all kind of events, of security events and vulnerabilities where the application access was restricted. There were only several users that were able to access a certain application. They would have their own passwords. And that application also restricted the access to the database, and the database was encrypted using an encryption key. So up until that period, everyone thought that it's okay. But it turns out that it was not enough. Why? Because the servers themselves that were running the application in the database, they were obviously had their own administrators, okay, and they've had their own what is called the privileged access, right? Today we have DevOps guys, we have IT, we have engineers, so on. But basically, back then there was the IT guys that had access to the servers themselves. And we've seen all kind back in 2000, at the beginning and before, we've seen all kind of events of administrative privileges that were used in order to basically steal and compromise all kind of systems. And that's why the privileged access management came to life, right? Basically, privileged access management means that there is some kind of mechanism that is supposed to record the session, to make sure that there's a big brother out there that is controlling the actual administrative tasks, so that there will be a difference between the application user and the administrative tasks that will be done. And well, most importantly, as you can understand, the local operating system administrator has their own secrets, and this is why privileged access management has their own secrets repository. And one of the most famous features with privileged access management is the ability to automatically rotate the local operating system passwords, okay? So again, once again, we started with protecting the data with encryption, then controlling the access to the data with authentication and identities, and then there's the special privileged access that actually is running the whole thing and need to be monitored. So to make things even more complete, then when you need to have those credentials, passwords, and that you need to protect, those administrators that need to be protected to protect their passwords and also to protect the encryption keys, then you're going to ask yourself, okay, so well, we asked ourselves back then in 2000, and it's the same solution basically up until recently. Also in the cloud, although there are all kinds of problems there, we're going to talk about that. But in terms of where do you put those secrets and keys, okay? Basically, you would need to have those credentials and passwords, you know, what we've mentioned as the privileged access management repository of secrets, all of that local operating system passwords, the SSH keys, and so on. You may say, okay, I would like to encrypt those also, and to protect it with a very special key that will be very strong. Okay, so now you have a key that encrypts the data, and then you have a key that encrypts your secrets, your authentication objects, your password and credentials. And then you ask yourself, okay, so where do I put that key? Now, there are all kinds of ways to protect keys, right? You can place those encryption keys within your configuration files, which is known to be bad practice because anyone can go ahead and just fetch those configuration files. Some of them are being public with time. There's local storage like Java Store and all kind of known repository that were known for years to be vulnerable for different types of attacks, memory leaks, and so on. And then there is the KMS, the key management system, which is definitely a good start, where you have an external system that keeps your key. And that system can either be software-based like KMS. There are all types of vendors that provide that. There is also the cloud service providers that provide that. And there's also an HSM, which is known to be most secure. It's a hardware solution that you can have within your data center. And that hardware solution specializes with storing the encryption keys and to never provide them. But you know what? That have been always the problem of KMS and HSM, eventually, after you place the encryption key within that box, you need to have a password, which is a secret again, in order to authenticate to that KMS and to that HSM. Sounds confusing, I know, but basically that was for years the problem, where you have the chicken and the egg problem, where you want to protect secrets and data. You encrypt them using an encryption key. That encryption key you place on a hardware device, and then you need a secret in order to authenticate to the hardware device. That problem has never been solved up recently, that there are all kind of beginning of those solutions, but this is kind of the paradox of the root of trust. Who is the root of trust? Who can you trust on your environment that would save your keys as is? So after those solutions were added and would and basically came to life, you've seen all kinds of vendors that provide key management systems and privileged access management and SSH management, where for SSH keys you had to protect those private and public ones, and who got those SSH keys. And you saw also some solutions in the last 20 years for certificate management. Not a lot, but quite recently we've seen a great rise in those also, where the HSM was the root of trust for all of those solutions. Now, you've for some of you who are familiar with privileged access management, for example, you can see there a great overlapping, where you see some privileged access management solution that also has SSH solution, SSH keys management, and some of the SSH keys management solutions actually overlap with certificate management. The reason, by the way, is that both of them require certificate authority. Someone needs to provide that certificate. Someone needs to do that. By the way, the private key that signs the certificate is actually being stored on the HSM. So I can continue that on and on regarding the overlapping of all of those worlds, but basically look how overlapped and how interconnected all of those solutions are, right? We used to think about encryption and data protection as something that is completely different and completely distinguished between data protection and identities management, but actually with time we see that in order to protect the data, those two solutions need to work together more and more. So that was the history up until several years. It was a complicated world, but you've had all kinds of siloed solutions to provide that. And then obviously came the cloud. Now the cloud made all of that a little bit more complicated. Why? Because there were several trends that basically brought secrets into enormous number in terms of usage. Suddenly you saw much more authentication running on the cloud environment. The number one reason, the first reason, is about the containerization. We've had the monolith, which was one single application without any internal components, and in the last 3 years you're going to see you're seeing basically lots of microservices and subcomponents within a certain application. So suddenly one monolith binary became segmented to many microservices and microfunctions that requires authentication between them. So suddenly you have much more components that need to authenticate with each other, hence lots of more secrets. So that was number one. Number two, well, hybrid cloud, multi-cloud, the use of more environments basically, provided that you don't just have the on-prem environment with your internal sub-segments. Suddenly the hybrid is here to stay, right? 5 years ago, people, when they talked about the cloud, they said, oh, so we're going to take our on-prem, we're going to provide it to the cloud, we're going to upload it to the cloud, migration, and then we're going to kill the on-prem. Today, we understand that the hybrid is here to stay. And more than this, we're seeing that phenomenon more and more. Large organizations do not count on one single cloud provider. You have more than one cloud provider. So suddenly, the number of environments became much higher than what we had. Again, a lot of more authentication is required between components and so on. Number three, obviously, the DevOps movement, the CI/CD and automation, meaning that suddenly we have much more machines that can do whatever they need to do. And in order for machines to do what they need to do, they require authentication. You suddenly use machine identities much more. There is much more demand for certificates, for machine identities. because of that thing, right? It's much less of manual work and so on. Zero trust that have become much more like a great trend in the last 3 years, you may say. It has been around for around 10 years, but in the last 3 years, a lot of talking about it. Zero trust, in a nutshell, basically means that you cannot trust any entity. There is no longer IP to IP anonymous access, rather than you need to authenticate. And again, authentication requires much more secrets. So those secrets and the big rise of those secrets basically provided us with the situation where we need those within our automation scripts, within the source codes. We need much more of those tokens and API keys and so on. And those are being also used within our workload management platforms, right? Any Kubernetes container requires it. Any Jenkins jobs, for instance, a CI process that runs within needs to access a certain code repository. In order to access that code repository, you need to have an API key. This is it. You need to have to approach your GitLab. You need to have an API key. Where does a Jenkins job save that API key? Okay, so they have their own storage within it, but basically you suddenly have a lot of silos within your organization with secrets within Jenkins and secrets within your Chef configuration management, the secrets within your Terraform, and so on for there. So anyway, together with all of this, you can basically see that secrets are sprawled away the environments, and this is how it looks like, and they obviously require the management of those secrets. Great. So identity and access management, to summarize, identity and access management definitely, as you can see, has a lot of problems today. When the resources, as you can see in front of you, they are ephemeral, obviously. It means that all of that automation that I've mentioned means that no manual work can be done. So any secrets that need to be provided, they need to be provided in an automated manner with an API first approach, so that every container, every workload management system, every configuration management system would be able to fetch those automatically with large scale. Now, number two, when we're talking about multi-cloud and hybrid cloud operation, there is no one perimeter that can be somehow protected. It means that the encryption process and the data protection processes, they need to be distributed. You need to be able to encrypt in on-prem and to decrypt on your cloud. You need and the opposite, right? So you need to be able to take that perimeter old approach and to be able to provide access from anywhere. There's also a very a new problem of the root of trust. Remember when we talked about that HSM, when we've had it within our on-prem, we've had our own hardware secured model, so it was considered to be very trustworthy. But today, when you have a distributed environment such as the cloud, suddenly you are not running your own hardware, and even if you're asking for cloud HSM from your cloud providers, basically they have access to your encryption keys. They are obliged to provide your encryption keys to the federal government. It is called Cloud Act. You can Google for that. But basically, since you're not really holding your own hardware, you cannot longer trust the existing distributed architecture and existing resources that you're using. So that's another problem that was provided in the realm of secrets management and root of trust and encryption. Now, one more thing that became more complicated, and the COVID, work from home, and obviously remote work and the zero trust world have made it very much, it's no longer easy to have a VPN for any one of your environments. When we had an on-prem, we had one VPN. It was quite easy. Today, we have distributed environments in a multi-hybrid cloud, and you need to have all kinds of people, external and internal employees, to perform all kind of privileged access, and you need to provide them permissions to all of that. So I think that it's clear that the problem is here. So at this point, I would happily provide you some context with a certain Gartner report that was written, especially in this world, called workload identities, the need to manage workload identities in that realm. That report was written about 9 months ago. It's quite new, by Gartner analyst named Eric Wallstrom. And basically what they said there, it was a one major conclusion, that there's a great chaos around secrets and keys and certificates. They were the ordinary tools, or the classic tools, as I've mentioned to you in the last few minutes, the certificate management, the SSH management, privileged access key management, and so on, where the new cloud environment, the ephemeral environment, requires that secrets management to be created. And as you can see from that very good diagram that Eric have provided there, that diagram basically summarized that secrets management it's like a Swiss Army knife of all of those use cases, all of those realms. So within secrets management, you would find use cases that provide some privileged access management use cases to protect local administrators' passwords. Secrets management would act as a certificate authority to provide certificates for the internal environment. Some secret management solutions have key management capabilities, and also some of them can provide you with HSM capabilities. So secrets management is definitely expanding, and I'll talk in a few more slides about the different definition that is coming to the market from secrets management. But basically, when we talk about it with a high-level architecture, what does a secret management mean? It will mean that there is a storage of any encrypted secret store that is able to either provide a fixed static secrets, or to dynamically create those secrets, to manage those encryption keys, to sign certificates, and so on, and to provide the service for two types of identities, both for humans and for machines. Okay, so secrets management that is trying to unify the whole thing, you would find there use cases for both of those. Again, it depends on the solution that you're looking at. The cloud service providers in general tend to look at it mostly for machine to machine, and the solutions provided by the cloud service providers are given specifically for encrypted key storage. Okay, not necessarily for certificates. They have different solutions for that. But again, I'll be happy to answer questions about that and to place the different solutions if you would like. Anyway, so two types of identities that need to be provided with those secrets, and then after humans and applications would get those credentials that are stored within those within that service, the secrets management service, then they would be able to authenticate and authorize to the internal environment and internal resources. Now, the first and most important characteristics or property within a good secret management solution is the ability to integrate with everything, meaning that every platform that you have should have a plugin to your secret management solution. Obviously, there need to be API that is very wide, because everything again will be like infrastructure as code, Terraform provider that you would need, and so on and so forth. Command line interface, SDK in multiple languages, because you're gonna ask your developers to stop placing those secrets within the code, and you would need them to basically use either Java SDK or whatever other language that you're using. Obviously today it will be Go, and many other modern languages that they're going to use. And if you want to make life easier, you would also want to have a very good web interface that would be able to provide to you all of that all together. The beauty in all of that is the authentication, right? It's okay and it's great that you have. It's the first thing would need to be like to be able to integrate and to fetch secrets within your Kubernetes, your Ansible, your Dockers, and so on. But eventually, you would always need to ask yourself, how would a certain machine authenticate to my secret management system? Remember when we talked about the secret zero problem, that bootstrapping problem, where you need to have an API key in order to access the secret management system. Then today, using cloud identities such as AWS roles and Azure identity and so on, you would be able, with a enterprise grade secret management solution, you would be able to integrate that and to be able to authenticate automatically and quite seamlessly a certain AWS role to your secret management system. You would not need to define a new identity. Those systems interconnect with each other. And in terms of human authentication, you would need to have your own and your team members to be able to fetch secrets and to get SSH certificates and so on. Then you should be able to authenticate using XAML and OpenID, basically for Okta, Ping, Azure AD, all of the big identity providers, and MFA and so on. So now I guess that I don't have a lot of time left, because we started at around 12 time here in Israel time. But just to have some wrap up, secrets management solution would need to have some kind of multi-region and a multi-cloud offering, because eventually, even if you're currently running within a single region, you will find yourself having another environment. It's enough that you're using hybrid, and you need to have support within your legacy environment as well as in your new cloud and multi-cloud environment. So it needs to be easily to scale, easily to replicate and backup and so on. This is a very good place for me also to recommend for you to seriously consider SaaS solution versus self-deployment one. That would provide that for you, because the business of secret management, because today the scalability is becoming crucial, because most of your traffic in terms of credentials and authentication and encryption would be initiated by machines automatically. You will need to have it highly scalable, and this is why it becomes more and more complicated to have such a solution on a production enterprise grade. So with that said, I'd like just to finalize the things that I've mentioned for you, just for you to better understand the different solutions today for secrets management. It looks, SM is the short for secret management. Some of the solutions that you would find in the market would be specific, coming from the privileged access management vendors. They would be very specific around saving or protecting specific strings and the ability to integrate to your DevOps environment, which is okay, but it does part of the privileged access management thing. It would not provide you any certificate authority or any key management capabilities, and you would still need to have siloed solution. Other solutions would provide secret management in cooperation with key management systems. So it means that you would again be able to manage and encrypt certain strings, but you would not enjoy any dynamic secret allocation, any just-in-time access. Those solutions again would not provide you the certificate management. So again, you would need to have siloed solution for different types of use cases. Today, we've seen in the last few years that there are also some secret management solutions that are able to provide some kind of in the middle between KMS, privileged access, and SSH management. They're able to provide you some certificate automation capabilities and so on. So there are solutions that are able to provide more use cases than the other ones. And what we are analyzing and seeing for the future is that in the very, very short term, you would be able to use it. Obviously, there is a solution that is able to look at things in a unified, much more unified perspective point of view, where this is how Akeyless is looking at things, where you would not need to basically have different solutions and different siloed solutions for that realm, rather than getting all of that on top of one single platform, that you would be able to get all of those solutions and to enjoy that within one single vendor. That would obviously make it much more simple for you to use. So thank you very much. If you have any further questions, if you have any thoughts that you would like to share, I'll be very happy if you can shoot me an email. I'm here for your thoughts. It's been a pleasure, and thank you for your time.